here we had started writing a code where our intention is uh, to write a code to teach the machine to classify whether the given image contains circles or ellipses. Okay, so for which what we did, we actually have a folder containing 2000 images, right? So out of which we have first 1000 images as circles and the remaining 1000 images, so they are the ellipses. Okay, and in addition to that, we have a matrix that is called as the type.mat. It's the name given, which contains a variable called t. Okay, so when I load it, you can see that the t basically has, it's a 2000 variable, sorry, it has 2000 columns, one row containing the category, right? See, first 1000 images are belonging to class 1 or the category 1, and the remaining 1000 images, they belong to the category 2. Okay, so you can see that specified over here. So just to specify which image belongs to which class, we have created a variable, okay, and saved that in a file. Okay, so that's about the database, right? And our intention being to use the deep learning technique, specifically using the convolutional neural networks. We want to use the convolutional neural networks or simply CNN or convnets to do this job. All right. Okay, so that's the definition of our problem, and we started writing the code, which you can see over here. All right, so let's run part by part to see what we had done, and then we'll proceed further. Okay, so first part, it's just clearing up all the variables and closing the windows and clearing the screen. Right, now we open this, we have to go inside this ellipses to get the details of database and the classes, right? So we cd goes into the ellipses. Uh, I read the type, uh, that's in .mat format. It reads to a file called as it's a variable called as type. Then I come back to the same page or the same folder where I am currently located, that is cd dot dot. I come out. Then I create a t as a variable, which is a categorical variable dependent on whatever is the content of t. Okay, so something is present in t, it will get converted into the categorical data like 1 and 0, right? Then, so this ellipses, right? Uh, we create the image data store considering all the images present in the folder called ellipses. Okay, and give them a label. Each image gets a label dependent on the variable t, because that's a categorical data. In the sense, first image class 0, second image class 0, third image class 0, maybe 1001 image class 1, like that 2000 class 1. All of them will be assigned a label, right? And how many labels are there? You count it using the label count variable. Okay, so count each label in this image data store. So it's a image data store is a inbuilt command to create the data store, right? So data set can be created which stores the complete address of each and every image, right, in a file. All right, so let's run this to see what exactly is going to happen. You can see IMDS is created. When I click on that, it actually creates files 2000 into one cell, which contains the address of each and every image. That's all. Okay, so this is what is an image data store, and the label count. I'll come back. I'll come back. So, so second. So initially what we do here, we want to gather the information about the data set. So what we first try to do here is we will move inside the particular folder, that is the ellipses. Okay, so we move inside that ellipses by using the cd command. So we load the types. Type contains zeros and ones, right? And we come back, we put it into the type folder. Now create a T, which is the categorical data. Okay, after that, now we create an image data store, right? That holds the addresses of each and every file, image file. What are the image file that we are trying to access? So it's the every ellipse or the circle image. Okay, so uh, this is an automatic building process. Otherwise, I need to type a code to look how many number of files are there. You have to put a for loop beginning from for I is equal to 1 to 2000. Do something, you need to do that, right? So that whole job can be you can make it automatically, right? You can ask the machine to do it automatically by just using a function call, that is image data store, which does this job automatically. You just have to give a specification saying that, okay, which is the folder, right? So that is ellipses, this is the folder name. So same name you need to give over here, right? And what are the labels of each of the data, because image data store has classes, right? So what are the names of the classes that you are going to write? Give what names you want to give. It's like labels is the keyword, and tell that T, whatever is present, whatever values we have given inside T, right? Those names will act like labels of each of the image. All right, and give a count, right? Label count is equal to count each label inside the IMDS. Again, you see that this is automatically calculating how many number of classes you have, and in each of the class how many images you have, right? Again, this is automatic, right? So you see, count each label inside the IMDS. I'll show you that. IMDS, if I open, you can see it has so many properties, out of which what we are interested is this files. So it saves the complete address, the complete path. Okay, that's one thing. And the next one will be the count label. Label count is the address name given. So there are two classes inside in this particular folder. Class Z named as class 0, 1000 images, class 1, 1000 images. Now, what's the advantage of this method? The advantage being, if at all I want to add a third class, right? Another class to this, simply copy the images into this folder. You don't have to write any code. You don't have to do any additional job. What it does, whenever the MATLAB runs this part of the code, it identifies, okay, there is a third label present, which means there is a third, a new category is being added to this. Okay, so it will automatically count how many images are there in that. You may not have 1000 images for, say, triangle, for a class called triangle. You may have just 500, but all the 500 you copy into that ellipses folder, automatically it will get detected. Okay, there is a new class. So 0, 1, and 2. Okay, so that's what we have done over here. Right, once it is done, now our intention is just to visualize. Let's say, right, again, this is optional code, nothing to do with our machine learning algorithm. This is again a MATLAB code to visualize what we have. I just want to verify whether really there are two classes, right? So this is, I create a figure, n into m, two sizes we declare, number of rows and columns. So I just want to sort it at random order, right? Maybe 5 into 4, totally 20 images I want to create. So for I is equal to 1 to 20, do a subplot, show the images, give a name to that. Okay, so that's what is being done here. Let me run this section so that when we run this, you can see an image that pops up. All right, as soon as we run, you can see that the 20 images arranged in the form of 5 rows, 4 columns, you can see, right? Any image number lesser than 1000 will be a circle. A image number more than 1001 will become an ellipse. You can see that that's what is happening here, because we try to plot image percentage d, which is basically we are trying to plot the image case of I, right? That is the image number, and percentage d. Okay, percentage d will be the type of that. Type will be class 0 or class 1. You can see both of them. Image 181, then colon 1 means class 1. So 1226, if you consider image 1226 colon 0, because it belongs to class 0. Okay. All right. Now, so after this, our next intention is to, so we have a data set and we arrange the data set in the format, but the data set should be converted into in a training set and the testing set. So for that, what we do, right, we'll move on to the next one. I'll run this. So here you can see that we basically read an image, right, in this. So img is equal to read image from the image database, right? So that will hold the address. img, as you can see here, img is like this. It's one of the image, right, which you can see. It's 32 columns and 32 rows. Why we did that? Because I don't know what is the size of image yet. We simply know that the ellipses is a folder containing the images, right? I don't know what's the size of the image. So for that, I read the img, one of the image I read. Okay. So now the img, if I try to read the size of this img, I will come to know that, right, what is the size, right? Why do you need the size? Because you have to define your convolutional neural networks input, right, according to the specific value, right, of the size of the image. So input layer should have the size. That's why I read this img. Okay, fine. Anyway, reading at the here itself is not required. You can even read this image in the next size. I'll do the modification, but okay. So what we do here, we define a factor, right? Out of the whole image, what percentage you want them to be used as a training and remaining will be used as a testing. So 0.8 means it is 80%, right? You have to give a factor, so it has to be less than 1. But anyway, when you talk in terms of the percentage, this becomes into 100. Okay, so 80% is factor for training. So this is factor train, which means remaining will become the testing. So the MATLAB will automatically take care of, okay, which 80% I have used and what are the remaining 20%, right? It automatically keeps track of that, which images have been used for training and what are remaining for testing. It automatically takes care of that. You don't have to worry. Okay, so how does it identify? It creates two variables, one for imds train in the image data store. 80% will be stored in this IMIDS train, remaining will be the test. You can give any name here, this is user defined. Okay, so just to track it, I have given the name train and test. So it can be splitted automatically by using a command called as split each label present inside the IMDS with this much percentage, 80%. Again, 80% is not one after the other, it is with the randomized feature. So randomly it will choose. It will select 2000 numbers automatically, right? Out of which 80 will be selected inside the IMDS train, remaining will be the IMDS test. Okay, I can show you that whatever is present in the IMDS train will not be in IMDS test. So you can see 1, 2, 5, 6, 7, 8, 9, 10. See, 11, 12 are not there. 13, 15, 16, 17, 18, 19, 20 is not there. 21, and so on. Now I'll open the IMD test, right? So it's a 20%. 20% of 2000 is just 400. Now you'll see whatever is there is not here, right? You can see. I'll just IMDS test. I open some. Yeah, IMDS train.files. 1, 2 we have, 3, 4 is not there. So the 3, 4 you can see here, right? So 3 and 4, right? Which belongs to the test category, right? Again, 11 and 12, 11, 12, 14 I can see in the test. So train, they are not there. See 9, 10, 11, 12 is not there. 13 is here. 14 is not there. 15 is here. So the 14 I can find here, and so on. So you can see that, right? Though it has generated something at random, it has taken care of which one belongs to which class, and there is no overlapping. In the sense, whatever image you use for training is not being used for testing. Okay, so if at all you have common things, it's like you tell something to the students, right? Okay, these are the questions to be coming and this is the answer. You will tell that and you ask the same question in the exam. That's what is if there is an overlap between training and testing, that's what is the case. But now you see we have completely separated, right? For training we use some images, testing we are not using them. That 20% is kept separately as a test. Okay, right. So actually for creation of the training and testing data, this particular command is actually not related. That's not related. That's actually related to this one. Okay, so here I'll create this img is equal to read image in the imds, right? Anyone. Okay, so one of the image is read. So img holds the complete image. Now if I say size of that img, it gives you 32 into 32. So image input layer should have the same size of the image. That's why we create an image input layer, right? That's actually a 2D layer whose size is equal to, right, size of this img. Okay, fine. Now what we did, we tried to plot this and we couldn't plot this layer graph, for which we actually missed something in the previous session. Now I'll try to overcome that issue. So that means there is what is called as a layer graph, and this layer graph requires a particular field called, I just have to specify a name to this. What's the name that you want to display? You have to specify. Okay, so I'll write image input. So that's the name that will be used to identify this particular layer by the MATLAB. Okay, so then again I need to specify same thing everywhere. Okay, so what I do, I'll copy this much, paste it. So name, what's the name you want to give? This is a convolutional layer, so I'm going to give a name, CONV. This is convolutional layer, layer number 1. Okay, that's because later on I can see that I have another layer, so I can give a name too. Okay, so then batch normalization layer, again I need a name. Okay, so this is BN1, easy to track. Okay, then a ReLU layer, once again same thing. This is name, first ReLU layer, that's why I'll give a name, say max pooling layer. This is max pool. All right, now I can copy the same things over here. So this is convolution layer number 2. Then we have batch normalization layer, second one. ReLU layer, second one. Then max pooling layer. Let me give a name as 2. Okay, then we have once again the convolutional layer coming into picture. Now this is con3 batch normalization. This is BN3. Then we have a ReLU layer for the third time. So name will be 3. Okay, similarly, now you see this is going to be a fully connected layer, right? So let's give it a name. This is, there is only one fully connected. Okay, then we have a softmax. For every layer you can do this. You have to do this if you want to plot, if you want to plot a layer graph. So this is softmax. Then so that will be your final layer. That's output. Okay, now I think we can directly go and plot this. So I have to create an object by this L graph, which is equal to layer graph of the layers. Then call a figure and plot of that object, that is L graph. L graph is your name. I can even give my name. Doesn't matter. Okay, fine. So let's. I think we ran still here, right? So the variables are visible. IMDS train and test are there. Yeah. So we'll run this. Okay. So when we run this, we can see that a layer graph created. You see that just now, whatever names we have given, right? We can see, right? So image input, con1, bn1, relu1, then max pool1. So this is one set, right? Then it is repeated, con2, bn2, relu2, max pool2, right? Whatever you have created over here, right? So you can see the same layers are there, right? So name given is here is image input. So I can see the image input name here. Okay. So and so on. You can even if you bring it over there, you can get the details as required. Right. Okay. So that's the creation of what is called as the layers. So we are fine with each and every layer because we have used this several times, right? What is a convolution? What's a batch normalization? ReLU, max pooling, etc. We are very familiar with each and every term. We also have seen the mathematics behind it, correct? All right. So after that, so our next intention is we want to perform the training of the convolutional neural network. But uh, the requirement of the when we try to write a program, we have to specify what is the training, what type of training I want to perform by providing what is called as a training option. So if you don't give the training option, right, the code is not going to work. That's the fundamental requirement from the MATLAB side. Okay. Yes. So now let us start writing the requirement of training by the name, right? We'll give options of training as options. So options is equal to, I need to, there is a function called training so training options. So what are the training options we have here? So first one is, first I need to specify what is the training method. Okay, first option is a training method. Okay, I'll come back to this. First I'll write what options we have. Okay, let me write a small pointer here so that you can note it down. Okay, so the first part of the training option, we can specify the first thing that we are going to specify here will be actually so in that first we are going to specify what is called as the training method. Right, we have the following options. One is the first one is SGDM. So this is a very common algorithm, stochastic gradient descent. Right, so also in this we have learned the concept when we studied the theory part. We have used a concept with the gradient descent. We also have considered what is called as a momentum. So this SGD is stochastic gradient descent. The M stands for momentum. So you are also considering the momentum part in this. Okay, that's the first option. And the second option, you can either you can use SGDM or you can even use ADAM. Right, that is adaptive moment estimation. Okay, then you have another option that you can use. This is RMS PROP, root mean square propagation. Okay, so you can use either of this. Then you have another option that you can specify here, that is called as the initial learning rate. So you know that higher learning rate means faster learning. But if you keep it very large, right, closer to 1, somewhere your learning may get stuck. Okay, that's called as a suboptimal point, wherein you increase, it exceeds, where you decrease, you come below this. You don't, since the step size or the learning rate is larger, you cannot. So normally what happens, the default rate of SGDM is 0.01. That's what you keep it as, right, approximately small value 0.0. Then you have another option that is called as, this is the third category, which you can specify, that is the called as max epoch. Right, so what is that? We know that it's a maximum number of epochs that machine can use for the training. In each of the epoch, right, the training is going to use the entire training set whatever you have. But you can subdivide that into the another category. What is that? If you remember, right, you can divide the whole training data set into small parts called as mini batch, correct? You can specify that as another parameter, right, in your training option. Right, all these things you have the complete flexibility to decide what you. Okay, then whenever the mini batch sizes are formed, do you want to shuffle? Right, so training data, you don't want to give it in the same order every time in every epoch. Okay, so D, the next one which you want to specify is whether you want to shuffle. Right, you can say yes or no. I'll tell you how to do that. Okay, so then if you don't shuffle, data will be used in the same order. If you shuffle, data gets shuffled every time you give for it. Right, normally what we have observed is that if you give a shuffling op, if you enable this shuffling option, accuracy and the overall optimization of the neural network is improved. Okay, then validation frequency is the next term, that is F. You can specify whether So we'll first say that whether you need to validate or not. If yes, right, definitely. After how many training samples you want to validate. So if you enter 10, it trains 10 samples, immediately it will validate whatever it has learned easy. It's something like I read 4 or 5 questions, then I try to recall, okay, whatever I read is, am I able to recall, right? So it's like that, validation frequency. So this is enabled only when you validation data is used for the training. If you have not used, that's not. Okay. Then we have another parameter that is called as a verbose, right? So this is used to print uh, the status, to print the training status on screen. If you need, you can use it, otherwise you can neglect. Okay. Then you also have another option that whether you want to see the training graph, right? So there is another option, GH, that is a plot. As the machine gets trained, you have an option to see that in the form of a graph. Okay, so if you want to see that, you have to specify by using, I want to plot the training progress. I have to specify, yes, I want to see this. Okay, whenever you do that, you will be able to see it. So these are the various options we have. Now we see how to utilize them, how to use them in MATLAB. Okay, in the code. All right, so I have created the what is called as the training options variable I specified, but I never wrote. The first one, as you know, I start with SGDM. Definitely you can change this. Okay, as so I'll go to the next. I try to give the specifications one by one in next lines. Okay, so the next one I want to specify is initial learning rate. The command is ini. Note that some of the letters are capital in the middle. Okay, it has to be in the same. Okay, so I'll start with maybe 0.01. Nothing happens, right? It's not wrong if you give a larger number, but don't give too large, like zero point 0.9, zero point 0.8. Okay, initial learn rate. Then I want to give a mini batch size. So mini batch size, say any number will work fine. So normally we give 8, 16, or 32 and so on. Okay, specify a 2 to the power number, that's a convention. Okay, then you tell how many epochs mini a GCH. Initial learn rate is recognized, but mini batch size is not. GCH SIZE. Everything is correct. Okay, let's see. Then I want to give max epochs. Okay. Max epochs. Let me give that as 5. I want to shuffle. Okay. And you have to specify how you want to shuffle. All right. So I have to say for every epoch. Then, okay, let me define what is called as the validation data. Right, I want to validate now. So validation data will be IMDS. I use the testing data for validation as well. It's okay. You can even give the training data itself, right? That you can use. Then I want to say what is a validation frequency. Validation frequency. I want to use say 2. Every 2 training, I just want to use this. Okay. Then validation frequency. I want to visualize. Let me see. Let me show you what is meant by verbose. So you know that this is a display. So I'll write true. Then I want to see the plots. This is training. The complete training progress I want to visualize. What's the something is okay, after SGDM I need to put a let's do this. All right. Now, so the options have been specified, right? I will directly train. So the command to train is net is equal to train network, IMDS train, comma layers, comma the option. Specify in this fashion. Now you see what happens, I'll tell you. So it will use all of them. The validation frequency, etc. will be used. But you will see I have specified verbose true. So as soon as the training starts, you can see that in this command window, right? I'll clear the command window. You can see a table that comes up showing you with the details. Okay, so I think okay, so that's the first thing, right? And then we will also see the plot that's coming up. I'll show you the plot at the end. Okay, let's train. Spelling error. Okay, so it automatically activated the GPU present in my system. Okay, so if you have a GPU, training will be faster. Okay, otherwise it's going to take some time, right? Now you can see on the screen a table is being created, isn't it? So table is created. Now you can see first epoch is over. Iteration number 1, what's the time taken, etc. Complete details you can see in the command window. In the command window. Now below you can see that it's getting added up, right? It moves up one by one. Now you see 1 1 1 in the first column. Here. See the last these things. You can see, right? Now I'm highlighting. Can you see? Now, can you see the MATLAB window? So last, you see, now I am actually expanding that, right? One table is being created. Initializing input data normalization. After that, below that, one table is being created. Okay, there is some delay. It may come. This indicates that the training is it's going on. Initially, you can see that in the first epoch number one. Initially, you can see that this is accuracy, training accuracy. This was very less, around 45. It started with 45, right? You can see that, right? It started with a very small 45, somewhere here. Okay, later on it increased as the training progressed. There is a lot of variation. The black color is the one which is a validation. I enabled validation, right? So validate the data. So that's what is happening here. You can see that, right? The validation and the training are very close. Now you can see that the training iterations are, right, 500 iterations, out of which 171th iteration is going on. This is the one small indicator showing that how much is over, right? Then you can see that it's also giving you the complete details. So training at this time it started, and this is the elapsed time, right? So far 5 epochs have been defined, out of which this is the second epoch. Iterations per epoch is, right, 100. Maximum iterations is 500, right? Validation, everything, every detail you come to know here. So the if your hardware supports has a GPU, it is using GPU. Mine has a GPU, so it's running on that GPU. If you don't, any system which does not have a GPU will show a CPU only, right? If the configuration of our hardware has multiple GPU, you definitely have an option to share the job between multiple GPU. You just have to write a code for that. I'll show you that code later, right? What options you have, how to enable GPU, single GPU, CPU. I have an option to say that, okay, don't, I have a GPU, but don't use it. Use the only CPU part. I can definitely specify, but that's going to take a lot of time. It will be a slower process. So by default, it will identify if there is a GPU and it will run. Okay, so etc. So those are the various parameters. So there is a second graph which is below. You can see that this is a loss graph. Initially, you have a larger loss. As the time progresses, the loss reduces. Loss, the cost function which we had calculated in the theory part, right? So that's how it's running. It will take some time now because we are still at the iteration number 205, right? And until we reach iteration number 500, it will not show you any results. Okay, just a second. I'll try to share the MATLAB window once again. Yeah, can you see the MATLAB screen now? Yeah, it has been shared. Can you see now? I don't know what's the issue because the other screen immediately came up. Now it's not coming. I will cancel. I will share again. How about now? Don't know what's happening. Okay, I'll share you the old screen itself once again. Okay, so that the training at least you can see, right? So Visible? It's saying that it is getting shared. Anyway, now we reached up to 271 out of 500. So 10 minutes, it's approximately, it might require 10 more minutes to finish this thing. And I'll share you one photo. Okay. That gives you the current status of the training. So this is epoch number 3 ongoing. And so the time taken, whatever is the accuracy, you can see there, right? Accuracy is approximately 99.5%. Even the next column is a mini batch loss, etc. So the first accuracy, what you see 100% everywhere, is the batch size accuracy. Next one is the validation accuracy, which is almost 99.75 more. Okay, the current one. Now we entered into the fourth iteration. Now we are at 375th iteration out of 500. It's going to take 5 minutes more. Yeah, you can see. Ah, okay, fantastic. Yeah, please tell me. Or 65. Yeah, just few minutes. Okay, we'll finish that. So in the middle, you can see that there is a slight variation in the learning, because you can see over there. Where is it? Okay, over here you can see that right, there was slight increase in the error, right, around 400. Slightly increased, decreased, then slightly increased, and again decreased. That can also be observed in the accuracy also. That affected accuracy. Accuracy was slightly reduced, right, and then once again increased. Whenever accuracy is reduced, you can see that the what you call, the error increases, accuracy decreases. So it's vice versa. Over here it was accuracy was decreased, whereas error increased. Then we can see that once again it is uh, yeah, right. So now the accuracy is once again looks higher. You can see both the columns over here, they are 100%, correct? So, and the final column, the error is very less, 0.0004, 0.0025, 0.0017. That's the cost value. So now you see it's 10 to the minus 5, which is much lesser. Okay, so it finished all this thing, right? So iterations are over, right? I'll close the training progress. That's a training progress window which pops up whenever uh, says it is not able to. Okay, right. So that's the completion of the training progress, wherein we whatever we entered, like the details, like uh, whatever details we entered over here, it has been taken care of during the training part. Okay, right. So in the next class, we will look at how to do the testing, because training is over. We want to make sure that, right, machine perform the testing as well, right? We want the testing to be performed, and we will test for the testing accuracy.